Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 United flight for Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to Zurich International Airport. Runway 14 for an Lszh localize and landing. So right now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, displays and the functions of the Boeing 787-900Z aircraft. I'm going to start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above this level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in tens, hundreds and thousands of feet per minute, all the steepness of the trigonometric angles in increase can climb and descend, the radio altitude above the ground level, the artificial horizon with the altitude indicator of the pitch ladder decrease, the bank angle decrease, the Lszh localizer, the horizontal localizer and vertical glide slope that receives the radio frequency transmitted from the threshold antennas, that transmit the radio frequency that we receive from the onboard antennas of the aircraft and help us to align the aircraft with the magnetic north pole heading of the runway we use for takeoff and for landing. So we're gonna have the runway 14 in Lszh Airport, Zurich International Airport in Switzerland. We're gonna have the Lszh localizer, horizontal localizer, vertical glide slope, and the Lszh localizer crossbars in the primary flight display. We'll have also the flight director for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode annunciator with the autopilot and the auto throttle later and vertical navigation mode. We have also the HSI that displays the magnetic heading and track and the integrated display of the flight plan that we have that we're gonna create using the flight management computer, a flight plan or a flight path or a route for this aircraft, so we can follow it through the waypoints we're gonna create. You're gonna see the magenta or purple line we're gonna use for flying the aircraft. So we have the navigation display that displays the GPS position of the aircraft, the inertial reference position, the magnetic north pole and the geographic north pole and magnetic variation depending on where we are in the world. We have the terrain and weather reflections on the weather radar. You can see with red, green and yellow the terrain around you. You can see also the lakes, the rivers and the sea with blue. We have also the letter, the 4-letter name of the airports. You can see the airports around you in the terrain map. Where we are located right now, we have the Zurich International Airport, the Lszh in Switzerland. So we have the runway 14 for takeoff and landing. You're gonna see the runway length displayed in the navigation display, also its orientation, and we're gonna have also the display of the world stations, the ADFs, the MPPs, the waypoints which are horizontal and vertical navigation fixes. We're gonna select through the flight management computer some waypoints when we create the flight plan or the flight path or a route of the Boeing 787. So you will see when we're flying, we're gonna be flying through some waypoints, and we're gonna have the legs of the flight plan from one waypoint to the other. So we have also so this is the navigation aids displayed in the navigation display, the nav aids. We have also the display of other aircraft that fly around our own aircraft. Using the transporter, the ADSP and ADC transmit the receiver that transmits our frequency to other aircraft and the air traffic control and receives from other aircraft. We can make the calculations using the radio frequency received about the other aircraft, where they are located, the distance from our aircraft, whether they climb or descend or with respect to our aircraft. We can calculate the altitude difference in hundreds or thousands of feet with respect to our aircraft and to the other aircraft. Also, you can calculate the velocity between our aircraft and the other aircraft. It will give us a warning using the TCA system, the traffic collision advisor system, and we have an incoming collision with another aircraft in the air. So we have all these things. You will see also the horizontal vertical profile as we fly, the terrain around you, also the aircraft. You will see how far above the ground we're gonna be flying. Here you can see the primary flight display. I'm gonna show you later the airspeed, the altitude, the radio altitude, the pitch ladder, the bank angle in degrees, the left and the right engine indications here. So you can see the engines indications also. Also we have the flight management computer, the autopilot flight director system panel, the flight controls, the thrust levers. Here you can see we move forward or after the thrust levers. We can change the thrust commanded by the engines, by the fatics of the engines. The fatics are the flow these electronic control computers that control and monitor all the engine functions you see here, all the modes. Also the flight controls, I will show you how to use the side stick I'm using here to control the yoke of the Boeing 787 in flight, so you can have direction and control of the aircraft using the aerodynamic principles of flying. So I will explain you a little bit about that. So we have the autopilot flight director system panel, the flight management computer, the thrust levers over here, the yoke we can climb and descend. So you can see here we have the primary flight display. As you can see, we have the airspeed indicated, the airspeed selected from the autopilot flight director system panel. This is the airspeed tape. We have the altitude tape, the barometric altitude above the sea level, the vertical rate of climb descent of the aircraft. You will see the needle moving up when we climb, we move it down when we descend. Also the pitch ladder in degrees here, like 2.5, 5, 7.5, 10, 12.5, 17.5, over here 20 degrees for pitch up or pitch down. The bank roll in flight, the flight mode on a 0, with the autopilot and the autothrottle letter and vertical navigation modes. The HSI, you can see the heading selected, 360 degrees or 0, as it mentions here, selected heading. So you can see the values here, 210,000 feet and 360 degrees or 0 is like the same one like from the autopilot flight director system panel over here. You can see the autopilot engage and disengage, auto throttle left, auto throttle right, the flight director engage and disengage, the LNAV, VNAV, the airspeed guidance of the aircraft. So we have 200 knots here, climb continues, auto throttle, flight level change, heading select over here, 360 degrees, hold the bank angle in flight, altitude select. So altitude, heading and airspeed are the same like the primary flight display over here. Also this side you can see 200 knots, 10,000 feet, both sides. Agree, the captain and the first officer. So we have also you can see how far above the ground the aircraft will be flying, the terrain. Here in the navigation display, the terrain map, the airports, magnetic heading over here. How far above we will be flying, we will select the altitude later. Now we have 10,000 feet here, this line. It's also displayed here in the primary flight display, so these values, the purple, are from the autopilot flight director system panel, the airspeed, heading, vertical rate of climb, descent or flight path angle over here now is not selected, and the altitude also, altitude hold. So we have our localizer and approach for autoland. You'll see later the head-up display, the overhead panel. We're gonna make an engine start demonstration. Also you'll the overhead panel systems before we're going into flight with the Boeing 787-900 jet aircraft. You will see also the pedestal here, the thrust levers. So I will explain you also about the aerodynamics of the aircraft before we go to flight. I will explain you the Newton's physics and Bernoulli theory of fluids and aerodynamics, aerospace engineering, and the forces of flight, the physical forces of flight before going into flight. I will show you the outside view of the aircraft, and I will explain you about the aerodynamics, the Bernoulli theory of fluids. So we have over here, you can see the outside view of the aircraft. So you can see the aircraft wings hold the weight of the aircraft as we fly over here. the surface area of the wings, of the forward wings mainly. You can see also we have the minimum aerodynamic chord position, 23% of the Mach. Pretty much here is where the maximum aerodynamic lift occurs in the forward wings. It's also a position where the stall will begin in flight. The airflow becomes detached as we fly from the top surface of the wings, and the aircraft might go in fall, so we need to avoid the stall in flight. We have also the thrust vectors over here from the engines that propels the aircraft forward. We have the aerodynamics over here, the yaw control of the aircraft. We can climb and we can descend the aircraft around the lateral axis from one wingtip to the other wingtip. We can climb and we can descend like this. We can make turns to the right and turns to the left. In flight we can bang roll left and right like this. So to make bang roll we use the longitudinal axis that transverses from nose to tail through the center of gravity, as you can see. So you can make turns left and right, ailerons and spoilers, control left and right turn. We have the vertical axis through the center of gravity here. We make the yawing turns using the rudder pedals. Over here you can see the rudder moving left and right. The elevator over here for climb and descent. We have also the elevator trim like this, and the ailerons and the spoilers here and here, left and right wing. So you can see again climb and descent. We have the control column for climb and descent. This section of the yoke, the control column. Moving up we climb, moving down we descend through around the lateral or pitch axis of the aircraft. This way is the longitudinal roll axis, the control wheel, or the side stick left and right. Side stick up and down is the pitch axis. Also rudder pedals left and right over here, you can see is the yawing axis or vertical axis. You can use the rudder pedal. So elevator, climb and descent, ailerons and spoilers left and right turn, rudder pedals. You can see the side stick deflection is proportional to the yoke deflection. I will talk to you about now about the flight controls. So I need to finish about the aerodynamics. So we have the deflections from the airflows. Tells you the minimum aerodynamic chord position with the maximum aerodynamic lift occurs. We have the center of pressure that moves forward or aft as we fly, and the center of gravity pretty much around here. Vertically we have also, as I told you, the thrust vectors from the engines that move forward, and when we fly you can see the surface of the wings. The bottom surface is more flat, and also we have the flaps extended down here. So also we have an engulf attack like this when we fly. So we have higher pressure below the wings when we fly because we have lower airspeed below the wings using the Bernoulli theory of fluid, which pressurizes the aircraft wings and weight up into the air. So you can see the top surface of the wings is more curved, so the air is moving much faster above the wings. So we have lower pressure above the wings using Bernoulli theory of fluids. So this sucks the aircraft weight and wings up to the air. So this is the aerodynamics, the process of flight. So I will show you the flight controls now. I use the side stick logistic extensively to control the yoke of the Boeing 787 in Microsoft Flight Simulator X. So you will see I can control the elevator for climb and descent, the ailerons and the spoilers to make bang rolls, and the rudder pedals to make yawing turns using the rudder. Also in the rudder pedals we have the nose wheel steering, the tiller and the toe brakes. We have also the horizontal trim stabilizer. We can trim the horizontal tail elevator in the flight to balance the aircraft in flight. We have the manual trim switch and the automatic trim. So this is you can see the manual trim switch is here. Over here, this switch you can trim. As you fly, you trim the nose up. This way, you trim the nose down. You pitch the nose down this way. So you can see elevator pitch stream over here. So you can see it can move. This way it picks up the nose of the aircraft. It picks the elevator to pick up the nose up, and this way it picks the elevator to pick the nose down as you fly. You can see elevator pitch stream. Elevator trim, left click down, right click up. So it's the elevator trim. We have the head up, also the declutter here, and the autopilot disconnect here. These switches. So we have 3 switches for control. You can see we have also, as I told you, horizontal trim stabilizer. So this section trims the horizontal tails of the elevator as we are flying. We use the elevator here for climb descent. We have the elevator trim also to balance the aircraft in flight. So you can see the horizontal tail movement. Also the rudder and the alarms and the spoilers. So you can see the horizontal trim stabilizer, the switch. We have the alternate pitch trim over here. So you can trim the horizontal tail of the aircraft as we fly, and trim the nose up. You can see nose up here, nose down here this way. So you can trim either way. This way is nose up. We have also the parking brakes here, as you can see. This is the parking brakes. Also we have the horizontal trim stabilizer, this red carded switch, the cutoff switch for the horizontal trim stabilizer. So if you have a malfunction, you can see L2 and R2 stabilizer cutoff switch. If you have a failure of the auto trim system from the hydraulics over here that affect the L2 and R2 horizontal stabilizer trim, you will have a malfunction from the autopilot flight director system panel, the auto throttle, and the flight control computers. You can see we have the flight control computers here, primary flight control computers, and this is a fly-by-wire aircraft. So we'll have to come down here, and this is for all Boeing 737, 747, 757, 767, 777, and 787, all Boeing aircraft. Almost you open from normal to cutoff and use only the alternate. So you disconnect the flight control computers, the auto trim function. So you have only the manual trim switch, the alternate, as you can see, for stabilizing the aircraft in flight. Here and also here you can see here the manual trim switch. So you keep trimming the aircraft all the time from the manual trim channel of the flight control. From the direct, you have the normal, the alternate over here, and the direct control, like in the Airbus. So on this fly-by-wire aircraft, you move the side stick the yoke. You give a control input to the flight control computers to move the flight control surfaces accordingly in flight, whatever you need to do to balance the aircraft, for instance, or change the direction. So maybe it's more easy to fly a little bit than the starter in some conditions. So you will see we have also here secondary flight controls. We have the flaps here, as you can see. You can move the flaps up or down, how many degrees we like over here. You can see flaps movement. can see the flaps displayed here when they're moving up or moving down, retract or extend. So fully retract, fully extend, 30 degrees down. As you can see, flaps also horizontal trim, stabilizer display, rudder trim, cabin pressurization. We have some other controls, landing gear, extend, retract. So now the flaps are in extend transition. As you can see, they can retract also. You have the speed brakes also, as you can see. So this is the speed brakes over here, this funnel. So we have the thrust control also. As you can see, both NZIGs left and right. You will see the NZIGs indications increase here, like the N1, the exhaust gas temperature, N2, fuel flow, oil pressure, oil temperature, oil quantity, vibration of the engine. So you can see we have also the auto throttle disconnect over here. You can disconnect the auto throttle when flying the aircraft or in the ground. Pressing this switch, auto throttle disconnect here. We have the takeoff go around here and the thrust reverser also. So you can see we have also the flight management computer. I'm gonna input the flight plan here, and we have the mouse pad here, so I can control with the mouse pad the other functions here. You will see the purple indication here as it appears in the real aircraft, and you input using the keyboard here all the data you need for flying the aircraft, for making a flight plan. So use the mouse here and the flight management computer left and right side. You can use also for the displays here the mouse like this to make selections. We have also some other displays here, I'll show you later. Some more displays. So you can see also here we have the engines, we have the fuel control, the left and the right engine, fuel flow, the left and right fuel flow. We can turn off and on the engines, the fire extinguishers, left and right engine, the transporter. This is radio management panel, the rudder trim over here. So you can tune the navigation radios, the ILS, as you can see, weather radar, satellite, transporter. So we have also weather radar over here, as you can see. For this display I will show you later. Traffic, terrain, the barometric setting, the barometric altitude setting, uses for mercury, hectopascals, radio minimum, accept, reject warnings, and the range here, the map, range and menu, select what you want to display. So you will see the barometric pressure setting here, 29.92 inches of mercury. As you can see, we have this barometric altitude 1430 feet and the indicated airspeed. So I'll talk to you about the air data computer. So I need to show you the flight controls, a little bit more of the flight controls functions. A couple more minutes I will talk to you about the flight controls, how you use the side stick to control the elevator for climb descent. Also make bang rolls using the ailerons and the spoilers, the rudder pedals, horizontal trim stabilizer, the thrust levers, flaps, slats, speed brakes, nozzles steering the ground, parking brakes. So I use the side stick, as you can see, for making climbs and descents. The elevator over here, make turns left and right, ailerons and spoilers, the rudder pedals. So you can see also the outside. So before I show you one more time, maybe better explanation now, if you know what its control is doing. The horizontal stabilizer, what I show you also for the horizontal tail here the alternating normal manual trim. So we have, you can see the captain and the first officer move together in flight. They're interconnected. All flight controls, not like in the Airbus we have the side stick priority, and you can use either side if you need, unless you have a failure. They all move together. All flight controls, elevator, rudder, spoilers, rudder pedals. So maybe I will show you one more view of the flight controls of the Boeing 787. Then I will show you the rest of the systems of the aircraft. So you will see now one more nice view over here of the Boeing 787. As you can see, a better display. So you can see we can climb and we can descend the aircraft quite easily. It's very fast, the response of the flight controls, like in the side stick. Also when you want to make a turn like this, turn left and right like this, rudder pedals also. So quite easy, climb, descent. Also the outside view. The tails, the rudder. Also ailerons and spoilers here. So this is ailerons and spoilers, left and right turns over here. So hope you like the flight controls of the Boeing 787 as we use them to climb, descend, making turns. You will see later in flight we're gonna make a complete flight. You can see also we have the thrust levers here, the engines function. You can see the thrust levers moving forward or aft. So you can see this is the side stick that is identical to the Airbus. So I will show you all the flight controls, horizontal trim stabilizer, as you can see. Hope you like the Logitech Extreme 3D for controlling the Boeing 787, the flight controls of the aircraft. So this is enough for the flight controls right now, I believe. You can leave neutral also in flight. So I will show you now how to create a flight plan using the flight management computer. So I will input all the data of the aircraft for this flight in the flight management computer. That includes the takeoff gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing. In the center tank, like we have 30% in the left, 30% in the right, and 10% in the center tank. And so this flight management computer is going to calculate the loads from all these things. Also, as we're going to be flying, the aircraft will be burning fuel, so the flight management computer is going to recalculate the center of gravity of the aircraft. This also affects the autopilot flight director system panel functions and the auto throttle and the flight control computer's inputs. So we have the left and the right wing tank, as I told you, the center tank, This calculates the minimum dynamic chord position for takeoff, 23% of the Mach, and the horizontal trim stabilizer is going to be 4.35 degrees for pitching up the nose of the aircraft as we take off and then fly. The pitch trim of the aircraft is also from the auto trim system. It can be automatically set in flight, or we can use the manual trim switch. So we're gonna have 15 degrees of flaps for takeoff, 4.25 degrees of horizontal trim stabilizer, the aerodynamic core position. We're gonna use the takeoff runway 14 in the Zurich International Airport and Lszh in Switzerland. The runway length, the runway slope, the wind direction, speed, the barometric pressure, the density of the air, the temperature of the air, and also whether the runway is ice dry or wet is going to give us the takeoff speeds V1, V-rotate, and V2. We're going to have 9 degrees or less for pitch attitude, rotation, and takeoff. So we're going to have also the V2 plus 15 knots, like 150, 160 knots. Then we're gonna have the seats, the southern instrument departure, waypoints and fixes. I'm gonna insert in the flight management computer input the seats, the southern instrument departure, waypoints and fixes, and for the alert communication fixes and altitude and airspeed constraints for the initial departure and climb of the aircraft. Climb to the cruise level. We're gonna cruise like 25, 26, 27, 28, 29, 30,000 feet above the sea level. Then we're gonna transverse through some waypoints, make some turns, and we're gonna start the descent back to the airport elevation for approach and landing. So we'll descend to like 7 or 6,000 feet above the sea level, and the airport elevation is 1,430 feet, the runway. So we're gonna have the stars, the southern terminal arrival, waypoints and fixes for the terminal approach and landing of the aircraft in the airport, and include horizontal vertical navigation fixes and altitude and airspeed constraints. You will see we're gonna be aligned using these stars and also the ILS localizer and the runway heading of 136 degrees, the magnetic north pole heading we're gonna use. So we're gonna have the long final and the short final approach, the ILS localizer, the instrument line system that transmits radio frequencies from the runway 14 in Lszh, Switzerland, the ILS localizer of runway 14 of Lszh airport. We're gonna have the ILS localizer frequency for this specific runway and heading of 136 degrees. So we're gonna have the horizontal localizer to align us with the horizontal flight path and the glide slope to use it for the vertical approach and landing. So we're gonna be having also about 35 or 30 degrees of flaps extended for approach and landing, the landing gear down extended, and 9 degrees of pitch attitude or less for approach and landing, and an airspeed about 160 170 knots. So you're gonna see the complete flight plan of flight path route. We're gonna use here, as I showed you, the flight management computer to input all the data over here. So go on this display over here. So I'm going in this side of the cockpit. So you can see we have the mouse pad here, as I told you, the flight management computer, the keyboard of the flight management computer. So we can select here identity position, performance, takeoff, annunciate status, approach over here, navigation data, flight plans, load air traffic control, route plan, load plan, save flight plan. So we have the identity, Boeing 787 900 model. We have also some other functions here. So we have the index, position, Lszh, this airport, Lszh, the coordinates, GPS coordinates over here, the gate. So this aligns to the GPS position over here. We have the index again, the performance. So we can use performance, gross weight, fuel on board, zero fuel weight, reserves, cruising altitude. We're gonna use it after creating the route. Cost index. So we begin with the route. Lszh origin, departure airport over here. Copy paste back. Lszh, as you can see. Runway 14 over here for takeoff and then for landing. As you can see, we use departure and arrivals section. So this is departure arrival, so we can use departure runway 10, 14, 16, 28, 32. It's the right side. Also we have the seats, the are arranged by departure waypoints and fixes for the initial departure. So we use runway 14 and Zui to Alpha, the seats are arranged by departures. So we're gonna use departure arrival page again. So we have, let's see, it's arrival. So we have room approaches 162834, ILS 14 over here, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So you can use either. We'll use ILS 14, instrument landing system, runway 14, Trans-Samiki, Trans Negria over here. So you're gonna have the complete nice the stars, this other terminal, arrival, weapons and fixes. We have almost ready the legs here, the route. So we have the first, you can see route legs with blue, is not yet active, is gonna be with white, and also will display a purple here. So we have the first, second, third, fourth, fifth waypoint one by one, and the distance and the airspeed we have to be flying, the heading change in flight. So we have discontinuity here, copy paste. Then we have cruise, descent, approach, landing. So you will see we need to initialize. So we have zero fuel weight, 332.7 thousand pounds, plus fuel on board 34.4 thousand pounds, gross weight 357.2, reserves 5%. For this flight, cruising altitude 25,300, cost index 100%, fuel freezing temperature minus 37 degrees over here in flight. So we need to recirculate the fuel in flight so it won't freeze. You can see fuel freezing temperature here, and the center of gravity in flight, cruising center of gravity 80% for this cruising altitude. Use gross weight. So we can execute now. Press this execute button here. This is the purple again. So we have active route now with white and purple color here. So you see heading 135 degrees, 250 knots, 2 nautical miles over here, 1900 after takeoff. TRO 96, 1 nautical mile, 096 heading, 3 nautical miles, 014 heading, 5 nautical miles, Zui 052 heading, 6 nautical miles, 301 knots, 6000 alpha. Then we climb Negria, 301 knots, flight level 22,000. 226 nautical miles away from Zui, change heading 071, then make a right turn in the air 230 degrees, 12 nautical miles Namati, 320 knots, 11,800, then descend approach over here from the cruise level, 256 degrees, 6 nautical miles, 190 knots, 10,400, Zui 276 degrees, 9 nautical miles, 180, 7,000 alpha over here, down here. So we cross these waypoints, Z8701, 186,000 alpha. This is descent and approach now. TRA 290 degrees, 10 nautical miles, 180, 5,000 alpha, 235 degrees, C114, 6 nautical miles, 4,000 alpha. Osnem 136 degrees. We make a left turn here at Osnem. 5 nautical miles, 170 knots, 4,000 feet above the sea level. Then we have 136 degrees, runway 14, 8 nautical miles, 140 knots, 1,400 feet. So we approach and landing here at runway 14 for this elevation. We have also the flaps for takeoff, 15 degrees over here. Center of gravity 23%, 4.85 degrees for takeoff. V1, we rotate V2, so we have the takeoff speeds 130, V rotate and 140, V2, V1, 128 for this gross weight runway 14 in Lszh in Switzerland. So this is the takeoff data, as you can see. We have also again departure arrival, alternate, some few more functions, VNAV, progress, FMC communications, hold. We can select a waypoint here and hold in flight. Legs again, fix. We can set up fix in flight, and the word navigation radio we can use to tune the ILS or the word. So we go back in the cockpit here, virtual cockpit. As you can see, we have now the display of the navigation display. So over here, you will see the flight plan we have created. The airspeed is indicated. So we have the flight plan we created. You will see the purple line here, the Mazda. When we're gonna be flying, we'll see how far away we're gonna be flying. You can see the terrain map also. You can see here is Germany, here is France, here is Switzerland. Below here is Italy. So we're gonna be flying here the cruise altitude that we're gonna have later, and one waypoint by another, as we're gonna be flying across through some waypoints. So this is the active flight plan. You can see the Amity here, Mativ, Nigria. So this is from takeoff, climb, over here make turn, then descend, approach and landing here, Osnem, and maybe you can see Nigra over here. It's further away, so we look closer. We can look with the center also map, center view, 360 degrees. You will see the Nigra here, Amity, Mativ. So use again. Over here you can see the takeoff, the runway, then descent, approach and landing. So this is for navigation purposes. Also the vertical, the slope we're gonna be climbing or descent. Over here across through some waypoints. You can see the terrain in front of you with yellow, red and green color. We're gonna be flying. You're gonna see how far above we will be flying from the terrain. You can see also we have the display over here in the HSI, secondary flight plan. Over here the VOR IDF's tune. Also again we have a bit different structure of the primary flight display over here later, so you will see. We can see here also we have the runways. The runway we're gonna use for takeoff, taxiway, and the other runway. The elevation, terrain, the range, nautical miles, ground speed, the wind direction and speed. So you can see the taxiway in front of us, the runway we use for takeoff. As you can see in the GPS display, you see everything around you, the runways and the terrain map. Also, so you can see we have the taxiway in front of us. It's also displayed here in the GPS display, as you can see, and the aircraft symbol is here. So this is the taxiway, the runway we use for takeoff. So we have also, if we look further, we have the other plan display over here, other map setting. Over here, as you can see, airplane, some other functions. So this has the North Pole orientation. So we look closer over here, look further away also. You see how far away we're gonna be flying here with the plan. Other airports that I saw you. So you see this is the furthest away waypoint. Mickey Mativ, Zui, TRA, Lszh, Switzerland. So this is the same waypoints we have here. We can set using the mouse pad. The one, as you can see, select what we need, make changes. So we look closer now over here. As you can see, the review. So all the data you see here, all the air data you see, we have the air data computer here that has also GPS receivers, magnetic heading, North Pole, geographic North Pole, inertial reference alignment, laser gyroscope, laser alignment, also pitot, static pitot, dynamic pitot tubes for the airspeed and the barometric altitude, the vertical rate of climb descent, the angle of attack, radio altitude above ground level, GPS receivers, terrain map. So you see everything here, all the data are displayed from the data computer. So we have a few more things to see. You can see the displays here, the engines, left and right engine display. You can see the N1, which is I will talk to you about the FAREX. We have the FAREX installed in our Boeing 787-900 aircraft. The FAREX are the full authority digital electronic control computers. One is for engine gearbox, dual channel redundancy. When the channel phase, the other takes over, controls function, and displays all the engine data. You see in the upper and the lower ACAS, like the N1, which is low speed starters, low pressure compressor, and one of the turbofan to which engine exhaust gas temperature per engine, and two which is the high speed starters, high pressure compressor, and one of the turbofan to the engine. So you see here N1 is the low speed starters, low pressure compressor, and one of the turbofan to the engine exhaust gas temperature per engine. Into which is the high speed starters, high pressure compressor, and one of the turbofan to the engine, fuel flow per inch per 1000 kilograms, pounds, oil pressure, oil temperature, oil quantity, vibration of the N2 stage of the engine, also pressurizer. Over here you see cabin pressurization. We use in the manual mode. You will see what will happen, what will display. The outflow valves are in manual mode now. So we have also landing gear here, alternate gear, auto brakes, also displayed in the ACAS, not related to the engines directly, but so we have the outflow air from the 5th and 9th stage. So the FAREX can control the outflow valves air pressure from the 5th and 9th stage from the bleeder from the bypass from the front fan. So we need pressurizer from the engines for cabin pressurization, wing and engine RDIs, cabin pressurization, oxygen regulation in flight, also for air conditioning ventilation, for hydraulic fluid tanks pressurization. When we move the flight controls here, that you see, we need hydraulic fluid pressure, so it's air pressurized from the engines also, pressurizer, so you can move the flight controls around, the elevator, the tail. So also landing gear extend and retract, fast reverses from the engines, nose steering and parking, and normal braking, so hydraulics. Or also we have the APU, auxiliary power unit. We're gonna start the engines using the pressurizer and electric power from the APU. Also the FAREX control engine starts and shutdown fuel metering unit. Also as we climb the aircraft from the sea level all the way up to like 20, 30 or 40,000 feet above the sea level, like 8,000, 9,000, 10,000, 11, 12,000 meters above the sea level. As we climb higher, the pressure of the air, the density of the air and the oxygen becomes less than half the that of the sea level. Also the temperature of the air becomes freezing, like minus 30, minus 40, minus 50, minus 60 degrees below zero, below Celsius. So also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. Then you're going to be having a higher intake of air from the front fans for compression and combustion. So we're going to be having a different fuel air mixture request adjustment every second. So this is adjusted automatically by the FAREX of the engines, the full authority electronic control computers. Also the FAREX control as we fly into higher altitudes, the fuel will be freezing. So we have the fuel recirculation from the wing, left and right wing tank and the center tank to the engine components to heat up the fuel and cool down the engines also we do the same for lubricant and oil. It's automatically controlled by the FAREX, so it's a good thing to have the FAREX installed in your engines. Now we'll show you the overhead panel very quickly. We're gonna make an engine start demonstration. So we have the electrical, we start the APU now. We need the auxiliary power unit in the tail of the aircraft. We have left and right IDZ, 100 200 volts, 400 Hz frequency, the battery, primary flight control computers over here. As you can see, heading reference or data computer, flight control surfaces. So we have towing, power, FD door, passenger oxygen, window heat over here, rammer turbine. So we're gonna use hydraulics. As it tells you, primary and demand, engine driven, electrical driven. In the off position, you will see what the display, back to the on. They give you a fault, and then back to the auto. We have also here wing and engine on the ice over here, auto or on, as you can see. We have the lighting system, windshield wipers over here. So here we have also the recorders. We have the cargo and APU fire. We have electronic engine control for the engine, normal and alternate mode, and the auto start switches, we can start the engines later. As you're gonna see, if we turn on the APU, we have the fuel jettison. We can dump some fuel to lose weight in flight, make an emergency landing, select the nozzles also. Fuel tank left and right, wing fuel tank, center tank, fuel booster pumps, crossfeed valve. If we turn it on, we can feed either engine with other pump or either tank, and also balance the fuel between the left and right wing. So this is how to control the valves also here. We have the pressurizer from the engines from the APU, the PAX control, also cabin pressurization, climb descent, oxygen regulation. So we set in the automatic, we need to do nothing, it will be all automatic. We have also here the display of all the systems in a digital format display over here. So the overhead panel system, you see hydraulics, APU is running over here, oxygen liquid cooling. So we have the electrics here, left and right IGG, APU, so 130 200 volts, 400 Hz frequency, load set, contactors, controllers, drive, battery, and APU battery, aberrants and voltage, the hydraulics, left and right wing, left and right engine driven, electric C1 and C2, where the hydraulic fluid goes, which systems use it, and how much hydraulic pressure we have, 5100 psi mid system, and the quantity of hydraulic. Over here, fuel, left and right wing fuel tanks, center tanks, so we have 11,000, 11,000, and 11,000, total 33,700, low and high pressure fuel valves, left and right engine open from the center of the wing tank. They can feed the engines. The crossfeed valve is off, but we turn it on. You can feed either engine with either pump or either tank, or balance the fuel between the left and right wing. The APU is fed from the left wing using the DC motor. Also, you can see the minimum fuel temperature here, minus 37 degrees, and the fuel temperature minus 5 right now. So we need to recirculate the fuel to the engines from the wing tanks to heat it up automatically using the FAREX. Pressurizer, PAX control, oxygen, the doors are closed, the cabin can pressurize land gear, and nozzle here, pressure of the tires and temperature of the brakes. Flight controls here, so we have the flight controls. As we're going to be flying, you can see all flight controls are normal. There is normal function. You see how much the surface deflect, the wings, the elevator, the tail, also here, and the rudder trim and elevator trim. FS display, maintenance over here, systems, circuit breakers, here box systems display. Also checklist, one last thing to see before make the engine start demonstration, before start, after start, takeoff, descent, approach, landing. So this is all the digital displays we need to know. All the systems, we make an engine start demonstration right now over here. The lights on also, so we have 1 more minute, so we turn off both engines, so you can see, control to the off position. You can see the engines now are showing us some faults. So we have here, we'll see how to make an engine start over here, automatic demonstration. Because the hydraulics are off. So now we turn on the auto start system in the overhead panel, both auto start, left and right over here. So you'll see the amber indications. You will see we have pressurizer over here from the APU is admitted to the engines compressor to start the engine starters. So you can see we have only pressurizer right now. So above 20% we can let the fuel control, both left and right, on. We have the auto start on, and it takes a few more seconds. We're gonna start the engines. So auto start 30%, 36. So we have pressurizer now, and also fuel. So we have the auto start on. So you can see at about 62% we're gonna be having the engines running here. So this is running engines, both of them. So we use flaps for takeoff. parking brakes off, advance the thrust levers for takeoff over here. So we're gonna be takeoff over here. From this runway we take the runway clearance from the air traffic control. So we use the tiller here for nozzle steering. So we align very quickly. So we advance the thrust levers to full takeoff power like this. As you can see, align with the tiller and the rudder pedals, and hold the yoke down a little bit until 100 knots. So we have 80 knots, 90. Align with the rudder pedal. So we have V1. We rotate over here. So we rotate. We have positive rate of climb. Keep climbing. We can leave the control off, and it's no problem. Keeps climbing because we are trim right. So we have landing gear up over here. We have positive rate of climb, as you can see. And we keep climbing. As you can see, we are 1,400 feet above the ground, 1,700, 2,000 feet above the ground, 3,800 above the sea. We climb with 6,000, 5,000 feet per minute right now. The airspeed is 178 knots. The stall speed here, the flaps, the pitch altitude like 70 degrees. Now you can see how far above the terrain we are flying right now. Over here we are like 4,000 feet above the terrain. You can see the terrain, the aircraft and the terrain with green below you and around you. Also in front of you, if you look around further away, you will see more terrain display with more colors. You can see also the engines, left and right engines. So now we have the stall speed here, the wind also. So this is all the indications. We need to start the turn now. So we need to start the turn of the aircraft into the flight plan, as we need. So you can see the Zurich, Switzerland, the airport. So we start the turn. So you can see we can keep climbing even if we leave the flight controls off. A few more maybe. So you can leave the aircraft flight controls off. The aircraft keeps flying the way it should be. There's no problem with that. So we need to keep climbing here. 12,000 feet, as you can see. So you can see the stall speed here, our speed right now, the wind direction vector. We climb with 2,500 feet per minute, 13,000 feet cross through here. The next waypoint, intercept, then Zui. Here we have to be flying through. The engines indications, flight management computer here, autopilot set. So this is the view of the cockpit just after the takeoff here. You can see. So this is a nice view of the aircraft, the cockpit also. The Switzerland here, as you can see. So we have the Switzerland. We're gonna be flying through the lakes here. The Germany, my homeland over here, Bayern Munich. So the France. So we're gonna be having many countries to see as we keep flying. So we have 11 more minutes left. So 11 more minutes left for the flight to complete over here. As you can see, need to align here with the flight plan, with this line over here. So we're gonna be flying through this altitude. As we climb, we need to start the turn now. As you can see, we overflying here the Germany, the Bayern Munich, the France, the lakes, and we have a beautiful Germany view here. So make the turn here pretty much. Keep climbing. Use a little bit left rudder as we make the turn over here. So we have a better view now. So we leave behind the Germany and the France, and we're going back for the Swiss Alps, the Switzerland. Taking this turn over here, a little bit steeper. So we almost reached the cruise altitude, 25,000 feet. You can see where we are right now. We have to cross through all these waypoints, come back for landing. So here on this side. So we are level off manually here at the cruise level, and you can see we have the chemtrails now over here, the frozen vapors, as you can see from the aircraft, from the engines of the aircraft over here. So we are flying the Switzerland, Germany behind us, lakes, Bayern Munich, and France, and we're going for the airport, the Zurich International. Have a beautiful galactic view, as you can see. So this is a nicer view over here, and we need to start the descent now back to the airport, as you can see, as we are overflying here. So we're gonna start the descent now to the airport elevation, extend the speed brakes, so we have flaps up and flaps up. So we are 35,000 feet, as you can see, and we start the descent now back to the airport. So you can see this nicer view as we are descending over here. We need also to accelerate the aircraft a little bit. So we are descending for approach now. We have a few more minutes. Five minutes for approach and landing. We have a nice view here again of the cockpit of the Boeing 787. That's right. So we decrease the engine's thrust now as we are descending. So keep descending over here. Gonna make the turn now for approach and landing. So you see we take the turn here. Need to be aligned now with the waypoints over here, as you can see. So this is gonna be the terminal approach. We have also a little bit rudder, left rudder, as we turn. So you can see we need to follow over here these waypoints for approach and landing over here. Aligning also here with the center line with the runway. So we have 2 more minutes to go to the runway for landing. Over here, gonna be having landing gear down, a little bit more flaps. So it keeps flying manually, as you can see, and we are approaching here for the runway approach. Gonna be having the Lszh localizer also aligned, as you can see. So it's gonna be for approach and landing over here. So we are approaching here, as you can see. So we're gonna be having the Lszh localizer here. Also a few more flaps aligned with the Lszh localizer, as you can see. We have the Lszh localizer here, the frequency set over here, all the information we need to follow for approach and landing. So we just align with the runway. We have some heading, some side wind over here. So some side wind component we need to help the aircraft to align with the center line over here from time to time, as you can see. Side wind and wind gust, and we are approaching for landing. Align with the center line over here. We have about 20 more seconds for touchdown, as you can see. So we're gonna be flaring here. So we have the flare, touchdown, beautiful touchdown, parking brakes, thrust reverse,